Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening live session. Good evening to everybody. And today we are going to discuss very important topic, which is control charts. First, we will go deeper into the fundamentals of control charts, and there are few special tests which control chart gives us, which our naked eyes cannot identify those trends and patterns in the process, but control chart has that capability inbuilt which can identify those kinds of trends and patterns. So how that can be identified, that is something which we are going to discuss now. Everybody has heard about control chart at least once. Just give me yes in the chat box if you have heard about control chart at least once. दैट ओके कंट्रोल चार्ट करके कुछ होता है, ऐसा आपने सुना है, तो जस्ट गिव मी यस इन द चैट बॉक्स एवरीबॉडी. जस्ट गिव मी यस और नो इफ यू हैव नॉट हर्ड ऑफ इट. Just type no in the chat box. No, I have not heard of control chart in my life. This is the first time I am hearing this. Okay, Deepak ji has not heard of it. All right, no worries. We are going to सुपर. चलो सो आगे बढ़ते हैं. विल स्टार्ट विद द कंट्रोल चार्ट फंडामेंटल्स. नाउ व्हाट इज कंट्रोल चार्ट? कंट्रोल चार्ट is a tool basically. Control chart checks stability of the process. Just make a note of this. Stability. Now what is stability? What is control chart? I'm going to decode each and every element of it, and then we'll go for the what you can say, the special tests which are there in the control charts. Okay. Now, when we say control chart, we can say father of control chart is Mr. Walter Shewhart. We also called as control chart as Shewhart chart. Earlier it used to be called as Shewhart charts. Okay. Now Shewhart, Walter Shewhart is father of control chart and all the statistical process control. So you can write SPC here. SPC means statistical process control. Exactly. Very good. So stability of the process, which means the process is stable. All right. For example, let me give you a simple example. Let's take an example of a child. Okay. When the child is a notorious child, a naughty child, and a cool, calm, and composed child. Okay, just imagine these two children. Now, if I draw the what you can say, draw a graph of a stable child, it will look like this. Okay, so I will call it as stable. I'm just giving you an example of a child behavior and comparing that with a process behavior. And if I say this is called a unstable child behavior. Understand this? Okay, I'm just giving you example of a very simple, so you can connect with this. A process is a stable process, just like a child, a stable child, a cool, calm, composed child. Okay, अच्छा बच्चा जिसको बोलते हैं हम लोग. Okay. On the other side, unstable child, a notorious child, a naughty child who is doing all kinds of masti across. So if I put the graphs, it will look like this. Okay. So it will not be stable. Stability. So see, if the child is stable, you can predict the behavior of the child. But if the child is unstable, we cannot predict the behavior of that. Understand this? That means whether it is child or whether it is the process, if it is not stable, we cannot predict the behavior of that properly. Are you with me till now? Just give me yes in the chat box. If it is highly unstable, lot of variations are there, ups and downs, we will not be able to predict the behavior of that. Predict the behavior. Yes, everybody with me till now? Yes. Now the question came, the question in the statistician's mind was, what? So how do you define this variation? What variation is a stable variation? Because see, variation is a natural phenomena. We cannot eliminate variation from the process. We cannot eliminate that. So what variation is a stable variation and what variation is not stable variation? That's where Walter Shewhart came into picture. And what he defined, any process. Okay, if I plot the average value, which is x bar, any process within +3 and -3 standard deviation is a stable process. Any process, if it runs between +3 and -3 standard deviation, is said to be a stable process. If the process does not have that behavior, for example, let's look at this process. If this is the average, okay, and if this is the +3 and -3 standard deviation, so you can see a lot of data points are going beyond these lines. You can see here, this point is going beyond, this point is going beyond, this point is going beyond, right? So there are few points which are going beyond the +3 and -3 standard deviation. So what Walter Shewhart decided, any process which runs within +3 and -3 standard deviation from the mean, that is called a stable process. And the process which does not remain in that band, it's called as unstable process. Are you clear with this? Just type yes in the chat box. Clear? Stable meaning predictable, unstable meaning unpredictable. Very simple. In statistics, we collect the sample and we predict about the population behavior. We learn this basic fundamental in statistics in our green belt as well, where we collect the data into sample, that is called descriptive statistics, and we predict the behavior of the population, that is called inferential statistics. If the sample itself is having lot of haywire, what you can say, these kinds of variation, then our predictability will be very poor. We will not be able to predict about the behavior of the population. Population behavior also, our prediction also can become haywire. So to avoid that, we need to make the process stable. We need to ask the questions that whether this process is really stable or it is not stable, or exactly what is happening. Okay, so Walter Shewhart came out with this theory that anything which goes with +3 and -3 standard deviation is called as, and that is called, these two limits are called as control limits. So let me just wipe this off. If you want, you can just take a screenshot of this so that you can, okay, done. Let me see this. I think this can be saved now. Okay, anyways. Shalom. Now, these two bands which I'm talking about are called as control limits. Let me draw here again. If this is my X bar line, this is my control limit, which is called upper control limit. And this is my, let's say, lower control limit. Okay. And this is the process which runs between this. Okay. Now, upper control limit, the formula is X bar plus 3 times standard deviation, and lower control limit formula is X bar minus 3 times standard deviation. Okay. Let's take an example of it. Imagine, can you just calculate upper control and lower control for this process where X bar is equal to 30 and standard deviation is equal to 3. Can you calculate? Can you just calculate this upper control limit and lower control limit for this process? Everybody, just calculate and type in chat box. What will be UCL? What will be LCL? ध्यान से, जरा ध्यान से. Sigma is 3. X bar is 30. What is UCL? Yes, so X bar plus 3 standard deviation, which is 3 times standard deviation. So 3 multiplied by 3, it will be 9. Understand this? So upper control limit will be 39. Lower control limit will be 21. Are you clear, everybody? So it will be like 30 plus 3 into 3. So it will be 39. And here 30 minus 3 into 3, right? So 30 minus 3 into 3, which is, so is equal to 30 minus 9 equal to 21. So 39 and 21 upper control and 39 and lower control will be 21. So if all the data points are within this band, then that process is stable. If any data point, even a single data point is going beyond the control limit, that means that process is not stable. Clear, everybody? How it is calculated? Just give me yes in the chat box. Is it clear? Super. Super clear? Very, very good. Now, let me just remove this part. Okay. Now, whatever variation is there within these two bands, it is called common cause variation. And whatever variation is there outside of it, it is called special cause variation. Okay. So, just for your understanding, so this variation within this band, whatever variation is there, it's called as common cause variation. And anything which goes beyond this, if any data point, let's say if data point is like this data point is called as special cause variation. Okay. Now, just to give you example, let's say your office arrival timing, okay, and you have some kind of variation in office arrival. Now, every time there is always 5 to 10 minutes variation. If I ask you specifically why you came late by 2 minutes, you will not be having any answer for that. Why you came late by 2 minutes or 3 minutes or 5 minutes. But on one fine day, if you had a flat tire while coming to the office, and it took you another half an hour to change the tire in the middle of the road, and that is called a special cause variation because you came half an hour or 1 hour late to the office, and there is a special cause assigned to it. There is a special cause associated to it, and you can easily tell me that okay, this is because I got a flat tire in the middle of the road, and changing that tire took me some time, and that's why I came late. But if I ask you the reason for the common causes of the variation, you will not be able to tell. Are you clear, everybody with me? Just give me yes in the chat box. Yes, everybody with me with this example? Common causes? Yes? Now, here is a very deeper insight. Let me share with you. Okay? For special cause, now listen to me very, very carefully. Okay, let me ask you this question. With our Lean Six Sigma projects or Lean Six Sigma tools, which type of variation we want to attack? Do we want to attack special cause variation, or do we want to attack common cause variation with our Six Sigma tools? Type in the chat box. Is it special cause variation we want to attack, or is it common cause variation we want to attack? Everybody. सबको टाइप करना है. कॉमन कॉज, स्पेशल कॉज. common cause, special cause, special cause, common cause. Okay, so there is a 50-50 here. Huh? Few people are saying common cause, few people are saying special cause. Very good, very good. सुपर अच्छा. ओके. और हम में से कुछ लोग बोथ भी है, दोनों साइड में है. that's always a good to have, no? तो कॉमन भी बोला तो भी सी, मैंने बोला था ना सब बोथ रहेगा, तो मेरा एक तो बराबर आया, राइट? ओके. नाउ अंडरस्टैंड दिस. स्पेशल कॉज वेरिएशन. ओके. Ha, now this is very good point. Okay. For special cause variation, understand this. Identifying the causes of the special cause is easier than identifying the causes of the common cause. How many of you got it? Just type yes in the chat box. Identifying the cause of the special cause is easier than identifying the cause of the special cause, common cause. Are you clear with this? The same, let's go back to the same question. It is very easy to identify my tire got flat. That was the reason, easy to identify. But why did you come late by 5 minutes? Very difficult to identify. Now, in Lean Six Sigma, we most probably what we work here is on this common cause variation, and we still want to bring down this common cause variation because special cause variation anyway we take care of. Special cause variation anyway, it's taken care of. I'll give you a few example of special cause variation. Your tire got flat. You have a fever. Out of 30 days of, let's say, your body temperature, you have fever for 3 days. Okay, special cause variation. You have a machine breakdown, a special cause variation. Are you understanding? Now, for special cause variation, generally, we immediately take action and eliminate those causes. But for the common cause variation, it's a long-term journey. It's a complex process. Identifying the reasons behind it is very difficult. Okay. So Lean Six Sigma tools basically focus on reducing the common cause variation. How many of you got the bulb on moment here? Just type yes in the chat box. Special cause variation के लिए we don't need to identify causes. It's a very evident causes. Causes are very evident. Common cause variation, causes are very difficult to find. Bulb on. Lot of people got bulb on right now. Understand this. Okay, fundamentals. Super. Now, let me share with you some practical tool करके देखते हैं. Let me share with you a Six Sigma projects are for those causes which are not clear. Exactly, which are not clear, which are common causes. Okay, common causes which are very difficult to find. ये variation क्यों है? Okay, that's where we go deeper into those causes. Okay, now let me share one one file with you, and we will do a practical stuff here of control chart, and after that I will take you to the this one. Just a second, let me open that quickly. All right, चलो ये करते हैं अपना favorite file, chocolate वाला file. Let's open this file, process capability. Okay, these are the files which we use in our green belt, black belt hackathon as well. Just open this quickly. I will also open it. Once you opened it, let me know. Just type open in the chat box. Okay. Ha, Giriji, I will give you the clarity on this. I will share a document with you when it comes to X bar R chart where the sampling is done. See, I am talking about a very fundamental, the basic control chart, which is called as individual control chart. Okay. When it comes to the subgroup sampling where we take a sample, there we go for some X bar chart, X bar R chart, X bar S chart kind of a thing. And there a little different way the control limits are calculated. Okay, that's where this D2 etc. Come into picture. Okay, I will cover that. I will cover that. Everybody open the file. Let's type Vyas in the chat box. See this D2, D3, etc. These are the constant numbers. Okay. Identified by the statisticians. You just multiply with that constant number, you will get the direct answer. So it is kind of a shortcut given by the statisticians to us. I'll give you a table in which all those numbers have been given. Okay. हाँ नो फोन पे से नहीं होगा प्रणव जी फोन से नहीं होगा यू नीड अ लैपटॉप और डेस्कटॉप फॉर दिस नो फोन से मिनिट ऐप सपोर्ट नहीं करेगा डजेंट मैटर आपने आपसे ये देखिए बाद में आप ट्राई करिए अपने इफ यू डोंट हैव desktop laptop right now just observe what we are doing done everybody just give me yes in the chat box go to stat control chart variable chart for individual okay I have not okay my screen is not visible to you guys okay all right so here we go to stat control chart variable chart for individual just follow this path we learn the fundamentals first control chart variable chart for individual okay just click on that stat control chart variable chart for individual okay now here we need to select chocolate weight just double click on chocolate weight and click on OK. What is not opening, Soumya Soumya have you taken the access of Minitab right now on your laptop or desktop? Just give me yes. No, that's the reason it is not opening. Okay, don't worry, not to worry. I will ask the team members to share a path to open the open the laptop. Okay, open the Minitab. Okay, just a second. Just give me a second. All right, on your WhatsApp, guys, our team is sending you the procedure to access the Minitab. Okay, okay, on your WhatsApp in couple of minutes time. All right. So once you get it, then you will be able to open this file. Okay. So meanwhile, you can just send the message on this number. Okay. अपने ये व्हाट्सएप नंबर पे जिससे हमारा इनविटेशन आता है ना उस पे जस्ट हाई भेजिए एंड सेंड मी दी मिनिटैब एक्सेस वाला प्रोसीजर ऑलराइट हाँ सुपर सो just have a look at it till the time just have a look at it because it will take some time okay so let's say chocolate weight select करो और just click on OK. Very good. Very good. Super. Everybody got this? Just give me yes in the chat box. Now, is this process stable or not stable? Is this process stable or not stable? Stable, not stable. Okay. Stable, not stable. Now, there is one point which is on the boundary line of upper control limit, right? If you remember, I said even one point, if it is there above the control limit, that makes the process unstable. Okay. So what we need to do is we need to basically investigate this point and eliminate it. Okay. We can see what happens is someday, once a while, these kinds of spike comes. Okay. So that point needs to be investigated, and that point can be removed from the data point, and you can declare the process is fairly stable. If those kinds of spikes are coming regularly, then you should not remove those kinds of points. Are you clear? One of the case say yes. But if there are regular spikes like this, then you should never eliminate those points from the data points, because that is the inherent characteristic of the process, which requires thorough investigation and some process, some kind of projects. Are you clear, everybody? Just give me yes in the chat box. Clear hai ye? Yahan tak clear hai? So this is a simple control chart we have understood. Now in the simple control chart, we can understand any data point which is going beyond control limit. Okay. But what if within this common cause variation, there are certain alarming traits, certain alarming patterns and the trends we want to identify. So for that matter, we have some special tests given in our Minitab. Okay. So how do we go for special test? Let's go back to the same data. Means even data points are equal to upper control. Does it mean answer? Yes. So Vaibhavji, it's like, see why it is shown in red, because even if it touching the upper control limit, it is unstable process. Okay. Exactly. So very good. What about special cause 2, 3, and 4? Where is 2, 3, and 4? Here only one I'm observing. Are you observing 2, 3, and 4 also? Special causes? We only have one data point which is touching the just touching the control limit. Okay. So we just have one. Now I am identifying within this common cause variation. Okay. See, our simple eyes, our naked eyes cannot identify the patterns and the trends, but the software has the capability. Okay. So how do we do that? That is where the special tests are available. So how do we access the special test? Just click on, click on this edit last dialog box, or just put Control E. Control E करिए, so you'll come to edit last dialog box. यहाँ पे edit last dialog box. See my cursor here, or you can just simply press Control plus E. You will come to the edit last dialog box where we have fed the data of the chocolate weight in grams. Now here on the right hand side, there is an eye chart option available. You can see my cursor here. Just click on eye chart option. And over here, you have parameter, estimate, limit, test, stages, box, cogs, display, storage. So here, just click on test. Now you will come to this page. Everybody with me till now, just give me yes in the chat box. Just click Control E. Then click on eye chart options. And click on test. You will come to this. Everybody just give me yes, if you are following me. All right. Now there are 8 different tests which are given, out of which only first test was by default selected. That test is saying 1 point greater than K standard deviation. Now K meaning, you can see on the right hand side, K is equal to 3. It is written in the box. Okay. That means 1 points greater than 3 standard deviation from the center point is the test number 1. And that's where one data point was shown in the red, because that data point has gone beyond 3 standard deviation. That's why it is shown as 1, because the first test has failed. Are you clear with this? Just type yes in the chat box. Clear? Because the first test has failed for that particular point, that's why it is showing number 1. If the second test would have failed, it would have shown number 2. Are you clear? Everybody with me? Now, by default, Minitab selects first test by default. Now, what we are going to do is, so yahan tak, are you with me, Anuj ji? Have you reached to this position, test wala position? Yes, very good. Now the first, if you can read that, it says 1 point. Okay, let me just write in blue. 1 point beyond K standard. So K is equal to 3. That means 1 point beyond 3 standard deviation, which is 3 sigma. So whenever you have 1 point going beyond 3 standard deviation from the center line, what is center line? Our X bar, our mean line, right? So whenever 1 point going beyond that line, so that means the first test has failed. So that's why this data point is shown as 1. 1 indicate the first test has failed. Clear? Just give me yes in the chat box. Very good. Now, what we will do is, we will select all the tests. Okay. Just go to this drop down menu, and you have perform all tests for special causes, perform select test for, selected test, or perform no test. So right now we will select perform all the tests. Just select this. And now we have selected all the tests in this. Now you click on OK and click on OK. Now within the common cause variation, now we are having 6, 6, 6, 6 and 5. Are you observing this? Everybody just give me yes in the chat box. Are you observing this? Very good. Now these are within control limits, but these are alarming situations. Are you understanding? Okay. Now, if you are from the safety, from a company where environment and health safety kind of guidelines are followed, we know there is something called accident and there is something called near miss. Okay, how many of you know this kind of terminology? Just give me yes in the chat box. How many of you have? Mosinji, we have selected all the tests. Go for all the tests. Select all the tests. Okay. So what I did is, we just went to eye chart option, go to test, and here we have selected all the tests. Okay. So all the tests are selected. Click on OK and then click on OK. Okay. Yes. So what is near miss? Near miss is a situation which has a potential to convert into accident. You have just missed it by a narrow margin. Okay. But if you do not take care of that, it might lead to an accident in the near future. That is called near miss. So in this case, if it goes beyond control limit, that is an accident. But these tests are just like near misses. Okay. They are not accidents yet, but there is a potential. If you do not, keep your focus there, it can create an accident and give you trouble for sure. All right. So here it's test number 6, test number 6, test number 5. And of course, 1 is already failed. We have seen that. Okay. Now we will go back to that, that test wala list, and we'll go one by one. What are the other tests? Okay. So let me open that test wala list once again. Go to test. So this is the test wala list. You can also open in front of you. Now the first one is very much clear to you. So इसको थोड़ा कम कर सकते हैं क्या? Let me just check. Okay, just a second. Okay. चलो ऐसा करके हम लोग देखते हैं, ठीक है? Super. So that you can check out that. So I go to test now. So I can see both. Okay. Now the first one is this one. So first one is clear. One data point beyond 3 standard deviations. So the first test has failed. Clear, everybody? Yes, first test is clear. That is very simple. It's a common, the first and very basic test. Any data point which goes beyond plus and minus 3 standard deviation is a special cause variation. Okay. That is called first test failed. What is the second test failed is K points. Now K meaning 9. You can see here on the right. Now these K points are by default. Statisticians have taken it by default. Can you change it? Yes, we can change it according to a requirement. But is it recommended? I will say no. It is not recommended unless and until you have a specific requirement of something. Then with the help of experts, with the help of expert statisticians, you can change those numbers. But ideally, it is not recommended to change these default numbers. Okay. Now, the second point is 9 points. So K is equal to 9. 9 points in a row on the same side of the center line. What does it mean? I'm talking about this second point here. This one. 9 points in a row on the same side of the center line. What does it indicate? Have you understood this? एक ही मतलब center line is our mean. All the 9 points are on only one side of the center line. What does it indicate? Type in the chat box. Biasness of the process. Okay. What else? What else? Imagine. Now imagine. Special test number 2. That's what I'm talking about. Imagine you are driving in the center of the highway in the midnight. Imagine. Understand this. You are driving in the center. Okay. And you are feeling a little sleepy. So you have drifted on the right hand side. You have drifted on the right hand side. Are you understanding? And 9 consecutive points you have drifted on one sided. So that means there is a process drift. There is some reason associated with it. It's an alarming situation. Are you clear with this? Are you clear? I see, you cannot have all the dots exactly on the center. There will always be some variation on left and right. But if all the data points are going on one side, 9 data points, that means there is some investigation required. Are you clear with this? Just type yes in the chat box. So if you would have found this kind of pattern, number 2 would have written over there. That is called 9 points in a row on the same side of the center line. Clear, everybody? Just type yes in the chat box if you are clear with the second test. When 9 points in the center go on one side, that is alarming situation according to software. See, yes, exactly. So skewness has started. So process is just becoming a little skewed. Very good, Santosh. Absolutely right. Okay. Now the third test is 6 data points. Can we see all these 9 points? Now it depends on the data set. If you have that kind of data set, you might have those kinds of tests. Okay. Now 6 points in a row, all increasing or all decreasing. What does it mean? It means, so all increasing ka matlab kya hai? Like this. Okay. This increasing or decreasing matlab like this. So what does it indicate? Again, the process is drifting on one side. Exactly. So the third point, what it is saying, when the 6 data points all are increasing on one side, either increasing or decreasing, that means there is some alarming situation. Look into the process. These are alarms set by the statisticians after lot of permutation, combination, R&D and experiments. That's why this default number has been set. Okay. Now the fourth test is 14 points alternating up and down, up and down, up and down, up and down. 14 points in a row. एक ऊपर एक नीचे, एक ऊपर एक नीचे, constantly. 14 points if you are observing, one up, one down, one up, one down. That is also an alarming situation. It might be a recording error. It might be a process stuck somewhere, or something is about to happen. You need to take care of it. But it should be continuous points increasing, and in graph there are some points in between. So see, so point number 3, if you are considering the test number 3, increasing and decreasing can be below or above the center line. It does not matter whether it is above or below. If 6 number of data points are continuously going up, 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 or down, 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 wherever in the pattern, that is alarming.
Sir, now in graph,
Haan.
the points which have been highlighted red.
Haan.
So in the test list, what we have selected, which one it is indicating? I mean
6 and 5. No, it is indicating. So I'm coming to the next point. 4 tests we have done. Now we are coming to 5th point where it is showing 1 5 over there.
Okay.
Okay. Yeah.
Okay.
So see, whichever test is failing, na, that number will get highlighted over there. Are you clear? Yes. Now coming back to test number 5, which is 2 out of 3 points. Understand this. 2 out of 3 points above 2 standard deviation. Now, what is 2 standard deviation? Just try to understand this. Upper control and lower control limit are set at 3 standard deviation. That means if I imagine these lines over here, this is 1 standard deviation. I'm just plotting the lines imaginary. Okay. This is 2 standard deviation, and this is upper control is 3 standard deviation. Similarly, on the lower side as well, okay, we have this is our 1 sigma, and this is our 2 sigma. All right. So I have just divided this entire graph into 6 sections. From the ground zero, which is x bar, 1 sigma on the above and below, 2 sigma on the above and below. So what it's saying is k point, k out of k plus 1, which means 2 out of 2 plus 1, which is 2 out of 3 points above 2 standard deviation from the center line. That means if you find 2 points, you can see here, this is point number 1 and this is point number 2. If you find 2 points above 2 standard deviation, so the second point will get highlighted that it is about to become a special cause variation, because the moment it reaches the 3 standard deviation, it is going to a special cause variation and process will become unstable. Okay. So it is giving is the alarm that 2 points have already gone beyond 2 standard deviation. Please take action. Clear? So this is test number 5, which is shown over here. Test number 5 failed. Are you clear with this? Just type yes in the chat box. 2 points above 2 standard deviation, 2 out of 3 points. Okay. Exactly. Any consecutive 2, out of 3 points, अगर 2 point आगे जाते हैं, So that means there is an alarming situation. That's it. That's test number 5 failing. Now, what is test number 6, which says 4 out of 5 points, 4 out of 5 points with, greater than 1 standard deviation. So what is greater than 1 standard deviation? So if you see this is 1 standard deviation का band है, ये है plus and minus 1 standard deviation, right? If 4 out of 5 data points have gone beyond 1 standard. So can you see here? Can you this part? Okay, so our eyes may not be able to identify those, but software is easily able to identify those, that 4 points out of 5 points have gone beyond 1 standard deviation, and that is also alarm for us. Okay, you have to investigate. So process is shifting over there. It has gone beyond 1 standard deviation. So 4 points. What about about 2 standard deviation? Even 2 points also go beyond, then it is an alarming situation. So it is step by step software is highlighting these points. Are you clear? The test number 6, which is 4 points out of 5 beyond 1 sigma. So वो ऊपर भी हो सकता है, नीचे भी हो सकता है. Okay, above and below, whichever is there. Okay, exactly. So software is showing you that this requires investigation. And investigation के लिए, what is investigation, by the way? Everybody knows CAPA, corrective and preventive action. Yes or no? Everybody knows this. CAPA सबको पता है. Yes. Corrective, preventive actions, yes. Everybody can do fishbone analysis. Even if without using this, can you just go back to the records on that very day? What happened? And if you can find out some special thing which you observe, which is not regularly happening, okay, that is called investigation. Investigation is not a rocket science. Okay, even if you can do some common practices of investigation, that also will be very useful. We should know the reason. That's the main purpose of it. Whenever there is such kinds of variation within common cause variation, there should be a practice for us that let's go back and investigate that. And then you take corrective measures to make sure the process is centered. Okay. Common cause only. Whichever upper and lower के बीच में जो भी है, it is common cause variation. All right. Yes. 8D problem solving. So there are a lot of things. What I'm saying, let's forget about all these tools. I'm just saying even commonsensical, logical questioning, investigation also is useful. We just have to be a little curious about what could be the reason for this. That's it. And go and identify 1 or 2 reasons behind it. And you will definitely find it. Okay. See, it can never happen that there is some variation and you are not able to find out the reason. Okay, this is very, very important. These are all common causes. Then why it is mentioned perform all the tests for special causes? Very good. These are the special tests for the common cause itself. Okay. See, it is all common causes only. These are all within the common causes. We are identifying the special patterns and the trends. All right. That's why it is like that. Okay. So 6, are you clear? Let's go to point number 7, test number 7, which is 15 points in a row within 1 standard deviation from the center line. Now, this is very, very interesting. 15 points in a row within 1 standard deviation. You will tell me. So here, 15 points in a row like this within 1 standard deviation. Okay. Now you will tell me that it's a fantastic result, right? Within 1 standard deviation, you have 15 data points in a row. That's a fantastic observation. Yes or no, everybody? Yes? Yes, 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 yes. It's a fantastic achievement. Yes or no? We have centered. We have centered, right? But what statisticians are saying, just compare your process with your child. Okay. Imagine आपका जो मस्ती करने वाला बच्चा है, वो उसने 2 घंटा कुछ भी मस्ती नहीं किया है, 3 घंटा. Is it a normal or it is abnormal? Tell me this. Is it normal or abnormal? Think about the child's perspective. Okay. If there is a naughty, notorious child is sitting idle for 3 hours, is it abnormal or normal? It is abnormal, and that requires investigation. Are you understanding this? Your process has to behave normally. Natural variation also has to be there. 15 data points consecutively within one standard deviation, it shows something is happening there, something is stuck, something is not getting recorded, there is something is missing. Investigate. Are you clear with this? Ideally, see, theoretically, best situation. Okay? Yes? Theoretically, best situation. See, sometimes you will find that everything is perfectly all right. Don't take any action, but investigate. Investigation, you may not take any action. It can be very natural as well. Okay? But investigation is required. If everything is absolutely normal, no problem at all, let it run like that. Okay? Yeah, it can be anything. It can be measurement system failure. It can be, your process is stuck. It can be, your encoder or your sensor is not collecting the data. Your IoT system has failed. There could be n number of reasons where you are not getting the. Okay. So you can do FMEA. So what we are saying is we can just investigate, and our overall understanding of our process deepens because of this. Okay. Now the last but not the least says 8 data points in a row greater than one standard deviation from the center, from the center line. Okay. So that means this band, beyond this band, this is one standard deviation. Okay. So 8 data points in a row, if they are going, okay, over here somewhere beyond one standard deviation, that is also test number 8 failing. Okay. So see, these are all these tests which are showing the pattern and the trends within those common variation patterns. So before it goes into special cause variation, we can identify them, we can take corrective preventive measures and bring the process to the center. Okay, are you clear? So this is how, so wherever it is shown in the red, those tests have failed. So this particular data has failed for test number 1, test number 5 and test number 6, which requires investigation. Or the remaining test, it has passed. Are you clear? Just give me yes in the chat box. Clear hai ye? Super clear? Very good. Now let me give you another data file. Let me give you another data file, and you need to tell me which test is failing. Open this data file called log transformation. There is a column called time. Uska eye chart banao, and which test is failing, let me know. All right. So this is a file given. मैं भी करता हूं आपके साथ, आप भी करिए, so that we both will get this. Super. Chalo. So let me also open that. I am also opening that file called log transformation. उसको भी एक बार करके देखते हैं. There's a column called time. We need to just do a control chart of that. So ये है कॉलम, उसका हमें कंट्रोल चार्ट बनाना है. ओके, टाइम कॉलम का टाइम. ऑलराइट, जस्ट गो टू द स्टैट, कंट्रोल चार्ट इंडिविजुअल and individual. All right, select time into that, go to eye chart option, go to test, select all the test, and say okay, and say okay. Everybody got it? So it shows test number 1 is failing, and here there is a test number 2 also is failing. Let me go back to test number 2. Test number 2 क्या है वो देखेंगे एक बार. Let's go to the option. Test number 2 says 9 points in a row in the same side of the center line. You can see here. It's clearly evident. You can see 9 points on the same point of from the center, same side of the center line. That is alarming. That's why test number 2 has failed. And of course, test number 1 is clearly very evident. Anything which goes beyond control limit is a special cause variation, right? And within common cause variation, test number 2 has failed, which is this. So this requires investigation. And you can see this has a special pattern as well. Even though it is a common cause, but there is something has gone wrong from data point number 2 to data point number 3 onwards. Okay, there is something wrong. It's kind of a process shift, and then the process has started behaving normally. Are you clear with this? Just give me yes in the chat box. Everybody got it? सुपर सुपर, समझ में आ गया ये. अभी आप कर सकते हो ये कंट्रोल चार्ट को एडवांस लेवल पे लेके गए हम लोग. सो कंट्रोल चार्ट, कॉमन कंट्रोल चार्ट्स तो हम लोग यूज करते ही है कॉमन कॉज एंड स्पेशल कॉज के लिए. नाउ विद इन कॉमन कॉज इज ऑल्सो हाउ यू कैन फाइंड आउट द ट्रेंड्स एंड पैटर्न्स. सो वी कैन यूज दिस टेस्ट एंड फाइंड आउट दोज पैटर्न्स एंड ट्रेंड्स. क्लियर? Very good, very good, super. Now, any question you have, you can just put that in the chat, or you can raise your hand and ask the questions. And I will be more than happy to answer those. Okay. Now we had in the beginning of the session, we had the question about X bar R and X bar S chart, right? So let me just share, let me just check out if I have that. I'll share the document as well. Okay. There are some control charts constants, okay, which are very commonly available. You can Google and find out as well. I'll share that. हाँ, एक second मैं आपको share करता हूँ, ठीक है? Now here we go. Just have a look at it, guys. In our green belt and black belt, we have, okay, see in our if you have the the continuous data. So we have I chart, IMR chart, okay. Then we have X bar R chart, X bar S chart. ये हमारे continuous charts है. If you have discrete data, then we have P chart, U chart, C chart, NP chart. These are the charts. Okay, generally these 7 or 8 charts will be used commonly. Okay, and this table you can refer when to use which chart. This table is available in your control phase of your green belt, control phase of your black belt. Okay, yes. So here what you can do is, yes, आपका कोई question है P chart, C chart, U chart के related, please put it in the chat box, or otherwise you can unmute and ask. Let me just give the answer to this. Now I chart का common ये होता है control limits का calculation, X bar plus 3 standard deviation, X bar minus 2 standard deviation, which I already explained you. But what about the other control charts? There is small difference between the control chart calculation, and this you can refer. Okay, this is a table for you to refer. Now, do you have to remember all these things? Not necessary, not required at all. Software is there. Software में पूरा feed किया गया है. So software calculates this. Okay. Now there, for example, X bar plus A to R. Now, what is R? R is the range of the data. Okay. What is A2? A2 is a constant. Let me show you that. Okay. Look at this. For example, this is X bar R control chart constant. Now, if you have, now these are very, very, they are commonly used constant, और ये data आपको Google पे भी मिल जाएगा. Okay. For example, if you have the data set of, let's say 15 data points, example I'm giving you. So you can refer this level. So your A2 value, okay, is 0.23. Okay. So if you go back again, if you have 15 data points as a sample, here you can take x bar plus 0.23 into the range of the data, x bar minus 0.23 into range of the data. This is the formula to calculate your what you can say control limit of x bar. When it comes to R, it is D4R, R remaining the range of the data set. D4 and D3 are the constant given here. Okay, if you have 15 data points, D3 will be 0.26 and D4 will be 1.65. Are you clear? So this file I will share in the today's sessions के recording के नीचे ये file भी डाल दूंगा आपको. So आप इसको refer कर सकते हो. Everybody clear with it? Just type yes in the chat box.
Sir, I have some questions.
हाँ जी, बताइए.
Can I share the screen?
Just a second. Let me just. Yes, now you can share. Please go ahead.
Sir, here, as you can see, IMR chart is there.
हाँ.
So, I mean, what is the value? I mean, range, whether it is okay or not. It should be within upper control limit and lower control limit. That's it.
Correct.
Or that's it. Anything is there.
So the process is looking very stable right now, as far as this IMR chart is concerned.
Okay. And second thing is in videos. Here you can see if my data is attribute and it is defect, and here constant sample size, if it is whether yes, we will go to U chart. If it is no, we will go to C chart, right? But in videos, I can see you are saying that if our data is not constant, not constant, you are saying U chart. If it is constant, it is C chart. Like that it is there.
This file you are referring from where? This particular
from videos, LMS portal.
LMS portal, is it?
Okay. I have taken screenshot actually.
So what I will do is I will, whatever file I will give you below the today's recording, no, just refer that. Okay.
Okay.
Yes. Yeah.
Okay. Maybe that correction is
required. Maybe required. Yes. Okay. It can be required. Yes.
Okay.
Okay.
Please share in the chat box.
Sure. मैं इसमें डाल देता हूँ. Okay. अपने जो LMS होगा ना, LMS में जो अपना मास्टर क्लास आर्काइव होगा ना, उसमें जो रिकॉर्डिंग हुआ उसके बिलो दैट आई विल पुट ऑल द फाइल्स. ओके. एंड ये 8 टेस्ट का भी एक डॉक्यूमेंट डाल दूंगा विच विल गिव यू ऑल द डिटेल्स ऑफ द टेस्ट. ओके. Please elaborate hypothesis testing with real scenarios. Hypothesis testing ka real scenarios will be, let's say, for example, I want to, let's say, I'm a purchase manager, okay? And there is a decision I have to take whether I should go for vendor 1 or vendor 2, all right? Now, vendor 1 is giving me the same quality material, so both are exactly matching with each other. As far as the costing is concerned, both are giving the similar kind of costing. Okay. Now only thing remaining is the what you can say the delivery time. Okay. So what I will do is, let's say I will collect the last 30 deliveries, the turnaround time, which is delivery time of vendor 1 and delivery time of vendor 2. I will collect 30 data points and then I will do, let's say, 2 sample t-test. In the 2 sample t-test, I will give the normal, what you can say, the first null hypothesis will be both these vendors have equal turnaround time or equal delivery time. That will be my null hypothesis. And my alternate hypothesis is there is a statistical difference between vendor 1 and vendor 2 delivery time. Okay, that will be my hypothesis. I will collect the data. I will feed the data in the Minitab software, and Minitab will give me, Minitab will compare this, will do the test, and Minitab will give us the p-value. Okay, now let's say p-value is 0.03. That means p-value is low, and our rhyming says p low null go. That means we have to reject the null hypothesis, which says both are basically both are equivalent. There is not much difference between both. But we have to reject that null hypothesis, and we can say that there is a statistically significant difference between these two, और जिसका एवरेज लीड टाइम कम होगा हम उसको ऑर्डर देंगे. इस प्रकार से आप प्रैक्टिकली हाइपोथेसिस टेस्टिंग का यूज करके डिसीजन ले सकते हो आपके बिजनेस में. Okay, Anuj ji, are you clear with this simple example of comparing two vendors, lead time of deliveries, and you can do 2 sample t-tests, and according to various, if there are 3 vendors, okay, if there are 3 vendors, you can do ANOVA. All right, अगर 3 vendor करने तो ANOVA कर सकते हो. If if there is 1 sample tested against 2, that is called pair t-test. So उस प्रकार से आप practically कर सकते हो. ठीक है? Super. Green belt test. Now something about green belt. See, this entire package has been designed such that you can give your test any day, anytime. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You select your time. Okay. There are people who give the test in the midnight or in Indian Standard Time because they are from other countries. Okay. So it does not matter. You select your time, you select your date. Absolutely, we are completely flexible. Second point, we have our Green Belt Hackathon, which is coming in the first week of July. Okay. So the people who have just recently admitted, you can target to complete maximum portion of the Green Belt. Okay. By the self-paced learning and by the live sessions. And you can attend the hackathon and you can give the examination so that in the first week of July itself, you will become Green Belt certified so that you can move onwards to the Black Belt, hackathon. Okay, Black Belt certification. So that whenever in the month of August, you can complete your Black Belt certification as well. Okay, so you can plan accordingly. Within next 1.5 months, you can complete your both certifications very easily. All right. There is no limit, Pranavji, for attempts as such. But I have seen only one candidate who has given 3 attempts. Okay. I have not seen, there are few candidates who go for second attempt, but I don't see more candidates. Most of them clear the examination within first attempt itself. Okay. Most of them, almost more than 90%, right? So not to worry, and there is no extra charges, nothing. You can decide whenever, and it's an open book test, so not to worry, MCQ type hai. Okay. As I said, Pramod ji, if you are ready, we can plan for your black belt examination, provided your green belt certification already is there with you, because that is a prerequisite to go for the black belt examination. All right. Yes. Any question which is हाँ, ग्रीन बेल्ट 1 घंटे का होता है, ब्लैक बेल्ट 2 घंटे का होता है. ग्रीन बेल्ट 1 hour, ब्लैक बेल्ट 2 hours. Okay. Yes. Can we get the feedback on the wrong answer? If you are very much curious, so you can just check with the mentor and they can pull out your question paper and share those answers with you. Okay. But we don't share with everybody. Okay. Huh. We can give you the percentage, how many percentage you have scored, but which question, which answer you have missed out, उतना deeper हम लोग सबको नहीं करते. अगर कोई ज़्यादा ही if you are very much curious about it, we can give it. Okay. Yes. Okay. Thank you very much, Santosh ji. And I want you also to become one. Okay, so that other people will say that okay, Santosh ji is the best Lean Six Sigma tutor or the mentor. Okay. Yeah. So before I close, tomorrow we have the yellow belt session, and we have the referral bonus scheme open. See, referral bonus scheme is not going to be open forever. Okay. So make sure you send lot of people in these few days and grab the opportunities before this referral bonus scheme closes. It is not 24/7 open. Okay. So make sure you grab this opportunity and get this 40% referral bonus and give advantage to the other people as well. Okay. D2 Girish ji abhi explain kiya na maine D2 wala example. See this one. See, these are the control chart constant, right? A2, D3, D4. If you see here, A3, B3, B4. See, all these are control charts constants available, and you can find out all the list available. Okay, जो भी आपको control chart चाहिए उसका आपको ये मिलेगा. See, and to be very honest, do we have to remember all these these formulae for control charts, etc.? बेसिक फंडा पता होना चाहिए, बट यू डिड नॉट टू रिमेंबर ऑल दिस थिंग्स. ओके. हाँ, एट्रीब्यूट चार्ट्स में वी हैव पी चार्ट, सी चार्ट, एनपी चार्ट एंड यू चार्ट. ओके, ये 4 एट्रीब्यूट चार्ट हम लोग कवर करते हैं, और उसके लिए एक स्पेशल सेशन भी अरेंज करेंगे हम लोग. ठीक है, कंट्रोल चार्ट, एट्रीब्यूट चार्ट उसको, एंड इवन ग्रीन बेल्ट हैकेथॉन में भी ये कवर होने ही वाला है एनीवे in the first week of July. So anyway, that will be covered in the control phase of it. Okay. So we'll cover all the charts, control charts, the continuous control charts as well as attribute control charts. See, attribute meaning discrete control charts basically, which is P chart, NP chart, C chart, U chart. That's it. Fair enough. Any other doubt you have, please get in touch with the mentors number, and we'll be more than happy to support you and guide you further. Okay. Thank you very much. By the way, there was one message. Tomorrow is 9:30 a.m. That's a common timing. 9:30 a.m. You can just check out with this number. If you want to send anybody, just send the message that I want to send this person or these couple of people for tomorrow's session. If they upgrade themselves, okay, you are entitled to get your 40% referral bonus. Okay. And another point I wanted, yes, last week there was a message about if you are serious about your consulting business launch program. Okay, even though you have just recently joined, but you have a vision to create. See, there is a offer going on in consulting business program launch. Okay, this week itself we are interviewing a lot of our students. Okay, we are qualifying them to that, and they are taking admission for that with this special offer prices. Okay, so if you are interested, please check out with the mentors number, and you can also set up a one-on-one call with me. Okay, that call will be around 40 minutes, 30 to 40 minutes call, in which I will explain you what needs to be done. Okay, what is the investment, how much time will be required for you to launch the program, etc. What will be the potential yearly earning you can make. Everything I will cover one-on-one, so that your questions also can be answered. Okay, if you're interested for that, just check out in the mentors number, and you can set up a one-on-one call with me, and we will yes. So if you have filled up the Google form, then you will receive a call from our team members. See, we have overwhelming response for that. Okay, from this, almost already we have received 200 to 300 people's inquiry, and connecting with them and discussing with them is becoming a little overwhelming. So we will come within next week or so. We'll come to you as well, and we'll have a call, and we will then discuss and close this. Okay, and we will send it again. A lot of people have missed out on filling up the form, so we'll send that message once again so that you can fill up the form and get your one-on-one done. All right. If you're serious about it, then only you should fill up that form and have this one-on-one, because your time as well as my time is very precious. So if you're not very serious and not urgent, so don't fill up that form. Whenever you are ready, then you can think about it. All right. So that's it from my side. Thank you very much. Keep learning, keep growing. Send a lot of people tomorrow for yellow belt session and get them upgraded. Till the time, this is Dhiresh Patil signing off. Bye bye. Take care. Good night.